Hey, Tim Berglund here. I want to show you how easy it is to scale a cluster in Confluent Cloud. I'm going to create what's called a basic cluster, which you can do on your own with nothing more than an email address and a credit card. What you will not see me doing is any cluster sizing at all. There isn't anything I have to do to a basic cluster to get it to scale as load increases. And there's no hourly cost apart from data stored and data transferred. This is difficult to demonstrate because watching an idle cluster sit there and not cost anything is, well, boring. But the point is that the price you pay is determined entirely by what you use. So I'm logged into my account and I'm going to add a cluster. Here are the only choices that I have to make to do that: a cloud provider, a region, and a type. As I said, I'm picking a basic cluster. And notice the base cost over there on the right, 0. You incur charges only by storing data or writing or reading data. If you don't use the cluster, it doesn't cost you anything. If you've ever heard people say that a cloud service scales to 0, this is what they mean. Now I'll launch that cluster and then get started getting the command line interface set up. I'm going to go through some of the basic steps that are given for me in the Confluent Cloud UI. Setting the environment, the default cluster, creating an API key, and don't worry, I've replaced that key by the time you're seeing this. And now finally, I'll create a topic. And now I'll produce some data to our test topic, then consume it back out. Kafka confirmed. Because I don't know 100 megabytes per second worth of poems, I've got a distributed loading tool that's connected to our cluster to help us out with the next step. Right now I'm ramping up to 20 megabytes per second of write and read traffic. I'm showing you this in the Confluent Cloud Cluster overview, which is just an awfully convenient way to see aggregate metrics on your cluster. If you wanted more detailed information, we do expose a metrics API that lets you see a lot more than this. You can integrate this API into your own observability tooling and create any views and alerts you need. But back to the overview. It updates once a minute, so I'm speeding it up a little bit just to keep things interesting. You can see the cluster has scaled automatically from its zero-cost initial state to now passing 20 megabytes per second from our test producers to our test consumers. If we look at the billing tab, we can now see that we're incurring just some slight costs since there's traffic. And looks like I got a few clusters on my account from previous tests. I should look into that. Now let's increase the load to 100 megabytes per second, which is the limit for a basic cluster. You can see the traffic happening here. Once again, I'm speeding this up, but I'm not hiding any of the click here to scale up your cluster buttons. I never had to leave this screen. Scaling just happens automatically. And this is a Kafka cluster that has brokers managing partitions and doing the work of reading and writing data. But I don't have to think about any of those details. Now, I've mentioned basic clusters, but there are also standard and dedicated clusters. Basic clusters, like the one so far in this demo, are great for development, testing, and relatively less mission-critical production workloads. They cost less to operate and they scale to 0, but they aren't covered by uptime SLAs and the durability that comes from replication across availability zones. Standard clusters are like basic clusters, but are replicated across availability zones and are covered by a 99.95% uptime guarantee. Dedicated clusters are fully customizable clusters intended for running mission-critical workloads at any scale, even exceeding a gigabyte per second. They also have additional security and compliance features like, for example, VPC peering to other network resources. I want to show you something new with the way dedicated clusters scale. Here I'm provisioning a small one with just a single CKU of capacity. What's a CKU, you may ask? Well, that's Confluent Cloud's provisioning unit. It just corresponds to a certain amount of ingress and egress traffic, a certain amount of storage, and other guarantees like those. They're all documented. There's a link in the UI, and you can see the details for yourself. It used to be that to expand a dedicated cluster beyond its initial size, you had to file a support ticket and ask a human to help you. Now, as you can see, I can just use the web interface to ask for however many more CKUs I want, up to the maximum. Here, I'm just increasing from 1 to 4. But hey, that's a 4x increase. Business must be good. Now, the best news is you can try all of this for free right now. Go to confluent.cloud in your browser, sign up, and you get $50 in usage credit to get started building things right away.